Welcome back, students. You thought you'd get away without doing any work, but you can't. Mr. Wild will find you. I will record lessons and I will force you to do them. Now, last time we met, you had homework. Pretty simple homework. It was only 8 problems. It was page 569, 570. You should have that at home with you. If you do not, because you finished it, you can still follow along as I go over it on the board. Now, I'm going to record myself writing on the board, but I've also got a screencast going, so it'll bounce back and forth so you can see what's going on. If you have any questions while we're going through it, please post those in the comments of this link in the Google Classroom, and I will address those as soon as I can. Obviously, this isn't in real time, so I'm not going to be able to answer them in real time. But do say things like, in number 2, where did you get the number 5? And I might say, well, the number 5 came from the fact that is the distance from one of the sides to the center of the regular polygon. I can address those questions if you're very specific for me, and we can review those in the video. All right, before we get going, I know I'm so sad that you can't be here with me, and I'm so sad that you're missing your classmates. So in order to get rid of that feeling of social isolation, what I've done is something not weird at all, not crazy at all. I've built my own set of students using things from the lost and found and classroom playground equipment. That's right. These are our friends. We've got Nerf, we've got Wilson, we've got Spalding, and we've got Voight, and they're going to be here working with me as we go through this, asking any questions they have. So please pay attention as we go over these problems. And I'm going to make these lessons much briefer than our ones in the classroom, guys. I want them to be quick. I want them to address what it is you need to do. And you can always just rewind and look at how I did one problem, and that kind of is applicable to all of the problems. So here we go. All right, number 1 is done for you, but if we go on to number 2, it is a pentagon, which means it has how many sides? 5. That is right, Spalding, good job. It has 5 sides. That means that you can take it and turn it into 5 congruent triangles. The only thing we really need is a side measure, which we have right here, and we also need the distance from one of the sides to the center of the pentagon, which we have right here. So now what we know is we're going to try and solve for the area of this single triangle. Once we solve for that single triangle, we can multiply it by 5 because it creates 5 triangles, and then we'll have our final answer. So right now what we have is the formula: area equals 1/2 base times height. Now, in case you've forgotten, I want to ask you if you know what it means when we say 1/2 times base times height. Yes, you, Wilson. That means you're also doing the same thing as dividing by 2. That's right. Multiplying by 1/2 is the same as dividing by 2. Very good job. So what I want to do first is use substitution to plug in the values for the variables. The base is located right here. It's 9 yards. So now as I rewrite the equation, it's 1/2, or rewrite the formula, it's 1/2 times 9 times the height, which is 6 2/10. All right, now we get to evaluate. Because of the commutative property, we can multiply these in any order we like. I can do 1/2 of 9, or I can do 1/2 of 6 2/10. I know 6 2/10 can be broken in half pretty easily, so I'm going to do that. 6 2/10 cut in half is going to give us 3 1/10 times 9. You see that I've simplified this, and I rewrite my equation every time so that I don't miss any steps. So now I have 3 1/10 times 9. 9 times 1 is 9. 9 times 3 is 27. Okay. Now I've got 279, but what I can't forget is the decimal. How many digits behind the decimal? 1. 27 9/10 our final answer? Yes. No, Voight, it is not. The final answer is, this is the final answer for the area of one triangle. We want to find the area of the entire polygon, which is comprised of 5 triangles. So we need to take that 27 9/10 and multiply it by 5. 5 times 9 is 45. So make a little space for ourselves. Remember, one of the things we talked about is that our papers can get a little bit messy sometimes when we have too much going on. So I encourage you to use scratch paper. I can really easily erase on the smartboard, so I'm going to do that. But I want to clear up a little bit of space. 5 times 9 is 45. Got to regroup my 4. Now I've got 4 10s hanging around up there. 5 times 7 is 35. Plus 4 is 39. 5 times 2 is 10. Plus those extra 3 up there. Actually, there are 3 10s. Those were 1s. 5 times 2 is 10. Plus 3 is 13. 1 digit behind the decimal. So there's 1 digit behind the decimal in our product. That means the total area of this pentagon is 139 and 5/10 square yards. Woo! Good job. We're going to move on and do number 3. And we're going to keep on rolling through this. Okay, count up your sides. What is the shape? Octagon. That's correct. It's an octagon because it has 8 sides. That means we already know our final answer is going to be comprised of 8 triangles, the area of 8 triangles. So again, we recognize our triangle formula is area equals 1/2 base times height. We use substitution to rewrite that, which becomes area equals 1/2 times 3 3/10 times 4. Class, is there anything that you think is easily cut in half? What do you want to do first? It's our choice because of the community property. Yeah, Nerf. Let's cut a 4 in half. That's right, Nerf. Good job. A 4 cut in half is obviously a 2. So now we have area equals 2 times, yeah, well, that's right, 2 times 3 3/10. This seems like a pretty easy setup now. So we've got 3 3/10 times 2. 2 times 3 is 6. 2 times 3 is 6. 1 digit behind the decimal. That means the area of a single triangle is 6 6/10 square inches. What we need to do, though, is remember we're finding the area of the entire octagon, which has 8 sides, which means we need to multiply 6 6/10 by 8. 8 times 6 is 48. Then we have 8 times 6, which is also 48, plus 4 is 52. 1 digit behind the decimal. That means our final answer is 52 8/10 square inches. We get rid of a lot of this because it's pretty messy here. We don't want it all junking up our page. All right, 52 8/10 is our final answer. I know number 5 caused a lot of people a lot of problems. So remember, when we have significant problems, we have to think about what we're given and how we can undo some pieces of it. For instance, this problem says we've got a dinner plate that is in the shape of a regular decagon. That means it has how many sides? 10. That's right, 10 sides. So the platter has an area of 161 square inches and a side length of 4 6/10 inches. Here's the first thing that comes to my mind. Okay, I want to break down all of the information. If I know it's a decagon, I know that it has 10 sides, as Spalding shared. I also know that means it has 10 congruent triangles. That means that area, 161 square inches, is comprised of 10 congruent triangles. Now this says, what is the area of each triangle and what is the height of each triangle? So let's break down the pieces. The very first thing I know is if 161 square inches is 10 triangles, what should we do to find the area of one triangle? That's right. We need to divide it by 10. You divide it by 10 because now we've broken 10 triangles all put together down into one single triangle. And we know anytime we're multiplying or dividing by 10, we're just moving place values. So 161 divided by 10, we're not going to use all of this. We know we're just losing one place value. So that means the area of one triangle, whoops, we need an L in there, is 16 1/10 inches, square inches. So now what we're going to do is take that and plug this into the area formula for a single triangle. Because remember, we want to make sure our answer matches our question. Our question was twofold. What is the area of each triangle? We've solved that pretty easily. Now we've got what is the height of each triangle. So we're going to take 16 and 1/10. We know that's the area. Area equals 1/2 times base times height. We don't know the height. We do, however, know the base. Each side length is a base. That is a base. So 1/2 times 4 6/10 times the height. All right. Now, again, I expect you to be participating at home, so I'm going to ask you. We've got 16 and 1/10 equals 1/2 times 4 6/10 times height. What do we need to do to solve this problem? That's right. Isolate the variable through inverse operations. I hope you said that out loud at home. I know this is like, it's like watching Dora the Explorer if Dora was an overweight middle-aged man, but I still expect you to respond at home just like you did with Dora and Boots as a kid. Okay, this is just less exciting, not nearly as many monkeys, but equally important to your learning. So again, we're going to solve this by isolating the variable through inverse operations. All right. Now again, I expect you to be participating at home, so I'm going to ask you. We've got 16 and 1/10 equals 1/2 times 4 6/10 times height. What do we need to do to solve this problem? That's right. Isolate the variable through inverse operations. I hope you said that out loud at home. I know this is like, it's like watching Dora the Explorer if Dora was an overweight middle-aged man, but I still expect you to respond at home just like you did with Dora and Boots as a kid. Okay, this is just less exciting, not nearly as many monkeys, but equally important to your learning. So again, we're going to solve this by isolating the variable through inverse operations. The first thing we need to do is simplify the problem. So when we look at this entire problem, we look at any part we can simplify. And the first thing I can simplify is I have 1/2 times 4 6/10, or half of 4 6/10. Well, I'm going to break this into two pieces. I've got 6/10 and I've got 4. Half of 6/10 is 3/10, and half of 4 is 2. So now I've got 16 and 1/10 equals 2 3/10 times h. Still isolating the variable through inverse operations. What's the operation currently taking place in this problem? That's right, kids, multiplication. So then what is the inverse operation? Very good, division. So we're going to divide each side by 2 3/10. It's going to take a little more work for me. We're putting 2 3/10 into 16 and 1/10. So the first thing we're going to do with a problem like this is what? Yes, get the decimal out of the divisor. Very good. We move a one place value here, which is the same as multiplying by 10. We also move a one place value on this side. Now we have 161 divided by 23. What am I going to look at 23 as in order to be able to easily use compatible facts? Yeah, that's right. 23 is most easily looked at as 25. I'm good at counting quarters, so I can count 25s. I'm going to find out how many 25s are in 161, and I'm going to assume that that'll give me a good starting place. So 25, 50, 75, 100, 125, 150, 175 is too much. So I'm going to try 6 times. 6 times 3 is 18. Regroup that 1. 6 times 2 is 12, plus 1 is 13. We're going to subtract. 6 gives us 5. We have 11 minus 8 is 3. 5 minus 3 is 2. 1 minus 1 is 0. What do you notice? Got a 23 and a 23. That means there's one more 23 in there, which means instead of 6, this should be 7. So our final answer here, the first answer was 16 and 1/10 square inches. And the second answer is height equals 7. That was a big problem with a lot of steps. What you're going to find in the upcoming days with our composite shapes, which we have coming up in today's lesson, as well as pieces like this, where we have regular polygons that break into individual triangles, it's a lot of steps, but it's not outside of anything you've already done. We just have to evaluate what steps we're going to do to get there. All right, let's switch over right now and take a look at the spiral review. I'm going to try and blast through that really quickly. I'm not worried about the top problem on the back side. We'll blast through the spiral review, make sure we remember what we're doing, and then we're going to hop on to today's lesson. Number 3 says, which inequalities have b equals 4 as one of its solutions? Remember, a solution is something that you can plug into an equation or an inequality that makes it true. So we're just going to replace b with 4 in each of these. If b becomes 4 here, 2 plus 4 is 6. So this would become 6 is greater than or equal to 2. That is true. 6 is greater than or equal to 2. 8 minus 4 is 4. 4 is less than or equal to 15. That is also true. 3 times b, which becomes 3 times 4, is 12. 12 is less than or equal to 14. And b minus 3 is greater than or equal to 5. Well, 4 minus 3 would become 1. 1 is not greater than or equal to 5. Number 4, each song that Tara downloads costs $1.25. She graphs the relationships that give the cost y in dollars of downloading X songs. Name one ordered pair that is a point on the graph of the relationship. So remember, class, what we're doing here is we are looking at X, Y relationships. So if we set it up with X, Y, and we know that Y is the amount of dollars, that means this 125 is going to be our Y. X is our number of songs. So one song is $1.25. You can continue in that vein to find the anything to lie on that graph by changing the X. So if you name any number 2, we know that would be 2 $1.25 or $1.25. So that'd be $2.50. If you continue that way with any number plugged into X, as long as you follow the rule, that'll be it for Y. Number 5 says, what is the area of triangle ABC? You'll notice they give you a rectangle. So if you follow your parallelogram formula, area equals base times height, you've got 6 times 10 is 60. That's for the entire parallelogram. We just want a triangle, which, as we remember, is half of a parallelogram. So that would be half of 60, which gives us 30 square feet. Finally, Marcia cut a trapezoid out of a piece of felt. The trapezoid has a height of 9 centimeters and bases of 6 and 11. What is the area of Marcia's felt trapezoid? Well, let's see. The best strategy, I think, for all of you at home is to go ahead and draw this out. If you haven't drawn it out, you're probably not giving yourself the best chance to succeed. So we've got a height of 9. We've also got bases of 6 and 11. Now at this point today, or yesterday rather, you were supposed to be quizzing on whether or not you remember your formulas. So hopefully you do remember that the trapezoid formula is area equals 1/2 times base 1 plus base 2 times height. Seems like a lot, but it's really not. Remember, the reason we do that is if you take a trapezoid, you duplicate it, you flip it, you put them together, you just get another parallelogram. So we're going to take these bases and put them together. Remember, it doesn't matter which you count as base 1 or base 2. They're both bases. But we're going to do 11 plus 6 is 17. We rewrite the formula again. 1/2 times 17 times 9. And then you're going to evaluate a second time. For me, I think the easiest thing to do is get rid of that fraction by doing half of 9, which we know is 4 5/10. Now you have 4 5/10 times 9, and you're just left with a little bit of math to do. Let's clear out a little space. Hopefully you've been using scratch paper at home, so your paper is not as messy as my board. 4 5/10 times 9. 9 times 5 is 45. We regroup that 4. 9 times 4 is 36, plus 4 is 40. We've got 1 digit behind the decimal, so we have that up here as well. So that means your final answer for your area of your trapezoid is 40 5/10 centimeters squared. All right, so that's it for reviewing the homework. In probably the link below this in your Google Classroom, you'll find the link for today's lesson. Remember, I'm going to keep it much briefer than normal. I know you don't have your math books at home, so it's not going to be as much. But I do need you to have paper and pencil ready when you click onto that, and let's make sure we work through the next piece together.